Hello. Hello and welcome to this video. In this video, we will learn about the array data type of PostgreSQL, which can be very useful and it can cause some problems also, particularly related to normalization. But in general, it's very useful to have arrays in Postgres. So the Postgres arrays are variable length multi-dimensional arrays, and they can be built on top of user-defined base type, num types, composite type, range type, or domain. So, for example, a table has been created in this documentation. It is sal_m, salaried employees. Name is text. Pay by quarter is an integer array. And schedule is a two-dimensional array of type text. So, as you can see, the syntax. So, this will create the table. Now, if you want to have the exact size of the array, you can specify that as well. Okay. Now, the current implementation ignores the supplied array size limit. That is, the behavior will be the same for unspecified length. The current implementation does not enforce the declared number of dimensions either. Arrays of a particular element type are considered to be of the same type regardless of size or number of dimensions. So declaring the array size or number of dimensions in create table is simply documentation. It does not affect runtime behavior. An alternative syntax which conforms to SQL standard is by using the keyword array. Can be used for one-dimensional arrays. Pay by quarter could have been defined like this. So it is better to define like that because it conforms to SQL standard. Or even simply you can specify like this because this 4 is not going to have any effect in the implementation. You can specify 4 for as a hint that this array should be of length 4. Now, to write an array value as a literal constant, enclose the array element values within curly braces and separate them by commas. If you now see, this is not unlike the C syntax for initializing structures. You can put double quotes around any element value and must do so if it contains commas or curly braces. More details are below. Just the general format of an array constant is the following. Inside single quotes, you have braces and then value 1, delimiter 1, value 2, delimiter 2. Where delim is the delimiter character for the type as recorded in the PD type entry among the standard data types provided in the PostgreSQL distribution. All use a comma except for type box, which uses a semicolon. Each value is a constant of the array element type or a subarray. So an example input is like this, where you have a matrix 3 by 3 rows. So this is an array element. This is also an array element. An array and array element both, because it is a two-dimensional array. Okay. To set an element of an array constant to null, write null for the element value. Any upper or lowercase variant of null will do. If you want an actual string value null, you must put double quotes around it. These kind of array constants are actually only a special case of generic type constant discussed in section 4. The constant is initially treated as a string and passed to the array through conversion routine. An explicit type specification may be necessary. Now there are some insert statements shown here for the sal_m. So this is the name and this is the pay by quarter, right? Yeah, pay by quarter. So 4 values for 4 quarters. And then this is the two-dimensional array, which is the schedule, meeting, launch, training, presentation. Then we have Carol, she has higher salary than Bill. And then we have the schedule, breakfast, consulting, meeting, launch. And if you select star from sal_m, this is what it would look like. Multi-dimensional arrays must have matching exchange for each dimension and mismatch causes an error. For example, so here we have meeting launch, but then in the second element we have meeting. So multi-dimensional arrays must have subarrays with matching dimensions. If the dimensions do not match, it will be an error. The array constructor syntax can also be used. So you have array, then brackets, and then you put the elements inside. Similarly, array, brackets, and elements inside. Notice that the array elements are ordinary SQL constants or expressions. For instance, string literals are single-quoted instead of double-quoted as they would be in array literal. The array constructor syntax is discussed in more detail in section 4. So we are not gone to section 4. Now, how do we access the array? So first we see that how to access a single element. So here we select the pay by quarter element 1 and it is not equal to payment pay by quarter 2. Now if you look at the insert element for bill, all the quarter payments are same. But for Carol, Carol it is 25,000 and for bill it is 10,000. Sorry about that. So Carol pay by quarter 1 is not equal to pay by quarter 2. There should be a difference. Let me see. 20,000 is not equal to 25,000. Their subscript numbers are written within square brackets. By default, PostgreSQL uses a one-based numbering convention for arrays. That is, an array of n elements start with array 1 and ends with array n. This is in difference along with most programming languages which are zero-based. So that you have to take care of. That arrays in PostgreSQL starts with 1. I think some programming language also starts the array with 1. I forget the name. This query is the third quarter pay of all the employees. Select pay by quarter 3 from cell and restaurant, and it selects the third quarter payment. We can also access arbitrary rectangular slices of an array or subarrays. An array slice is denoted by lower bound colon upper bound for one or more array dimensions. For example, this query is first item on bill schedule for the next 2 weeks. For the first 2 days of the week. Select schedule 1:2, 1:1 from sal underscore n and bill. So 1:2 for bill is and 1:1. Okay. So let's look at bill. So 1:2 means both the elements, and then 1:1 means making and chaining of each. Right? If any dimension is written as a slice, that is, it contains a column, then all dimensions are treated as slices. Any dimension that has only a single number, no column, is treated as being 1 from 1 to the number specified. For example, 2 is treated as 1:2 in this example. So here, if we say 1:2 and then 1:2, it will select entire array here as slices. To avoid confusion with the non-slice case, it is best to use slice syntax for all dimensions 1:2, 1:1, not 2, and 1:1. It is possible to omit the lower bound and or upper bound of a slice specifier. The missing bound is replaced by the lower or upper limit of the array subscript. For example, :2 and 2: will select, we will put the lower bound. So here it will become 1, here it will become 2. So it will select large indentation. Here it will become 1:2 and it will be 1:1, so it will select meeting and chaining. An array subscript expression will return null if the array itself or if any of the subscript expressions are null. Also, null is returned if a subscript is outside the array bounds. This case does not raise an error. For example, if schedule currently has the dimension 1:3, 1:2, then the referencing schedule 3 yields null. Similarly, an array reference with a round number of subscript fields the null rather than an error. An array slice expression likewise yields null if the array itself or any of the subscript expressions are null. However, in other cases, such as selecting an array slice that is completely outside the current array bounds, A slice expression yields an empty array instead of null. This does not match non-slice behavior and is done for historical reasons. So this you have to take care of. If an array slice is completely outside the array bounds, the slice expression will yield empty array. This is an exception, or rather exceptional rule. If the specified slice partially overlaps the array bound, then it is silently due to just the overlapping region instead of returning null. The current dimensions of any array value can be retrieved with the array underscore dims function. So select array underscore dims schedule from sal underscore n to name is equal to Carol, and we get the array dimension. Array dims produces a text field which is convenient for people to read, but perhaps inconvenient for programs. Dimensions can also be retrieved by array upper and array lower, which become the upper and lower bound of the dimensions respectively. So select array underscore upper schedule comma 1 from sal underscore n to name is equal to Carol. Array length will return the length of the specified array dimension. Select array length schedule comma 1 from sal underscore n to name is equal to Carol. Ordinality returns the total number of elements in an array across all dimensions. It is effectively the number of rows a call to unnest would yield. So if you unnest this, then 2 by 2 will be 4, so the ordinality will be 4. Now to modify the array can be replaced completely. So you set the salary of Carol here, and the first quarter salary is now 25,000. And third and fourth are 27,000. Then you can use array syntax as well, like this, and we can update a single element as well. So where this fourth quarter salary is increased from 10,000 to 50,000, or update in a slice. So you can update two elements also. Notice the difference here, places were used. Okay. The slice syntax with committed lower bound and upper bound can be used too, but only when updating an array that is not null or zero dimensional. Otherwise, there is no existing subscript limit to substitute. A stored array value can be enlarged by assigning to elements not already present. Any position between those previously present and the newly assigned elements will be filled with nulls. For example, if array myArray currently has 4 elements, it will have 6 elements after an update that assigns to myArray 6. MyArray 5 will contain null. So this is like JavaScript behavior where you set the array length to extra number of elements beyond the current number of elements. Then what happens is those extra positions are filled with empty items. Similarly, here extra or rather fifth position here will contain null. Currently, enlargement in this fashion is only allowed for one-dimensional array, not multi-dimensional arrays. Subscripted assignment allows creation of arrays that do not use one base subscript. For example, one might assign to myArray -2:7 to create an array with subscript values from -2 to 7. New array values can also be constructed using concatenation operator, that is double pipe. So select array 1, 2, and then we have pipe array 3, 4. So this will give you an array with 4 elements 1, 2, 3, 4. Similarly, you can concatenate 5, 6 with 1, 2, 3, 4. So this will give you a 2-dimensional array with 3 rows and 2 columns. The concatenation operator allows a single element to be pushed onto the beginning or end of a one-dimensional array. It also accepts two n-dimensional arrays or an n-dimensional and an n plus one dimensional array. When a single element is pushed onto either the beginning or end of a one-dimensional array, the result is an array with the same lower bound subscript as the array operand. For example, select array dims 1 is concatenated here with 0:1 of 2, 3. So if you look at the final dimensions, it is 0, 2. Again, if we concatenate 1, 2 with 3, then array dimension would be 1, 1, 3. When two arrays with equal number of dimensions are concatenated, The result retains the lower bound subscript of the left-hand operands of the dimension. The result is an array comprising every element of the left-hand operand followed by every element of the right-hand operand. For example, select array dims 1, 2, 3, 4, 5 is concatenated, so you have 5 elements, and then your array dims are 1, 2, 5. Similarly, if you concatenate these two arrays, which are one is two-dimensional and another, both are two-dimensional, but one has 2 elements, another has 3. So finally, there will be 5 elements, and then there will be each element having 2 elements. So first element is 5 arrays and 5 subarrays, and then we have each subarray containing 2 elements. When an n sub-dimensional array is put onto beginning or end of n plus 1 dimensional array, the result is analogous to element array case above. Each n-dimensional subarray is essentially an element of the n plus 1 dimensional array's outer dimensions. For example, this is the example like previous one. An array can also be constructed by using the functions array prepend, array append, or array cat. The first two only support one-dimensional array, but array cat supports multi-dimensional arrays. For example, we are appending 1 to 2, 3, we are appending 3 to 1, 2, and then we concatenate 1 to 3, 4, or we concatenate two-dimensional array, or we concatenate another example of two-dimensional array. In simple cases, the concatenation operator discussed above is preferred over direct use of these functions. However, because the concatenation operator is overloaded to solve all 3 cases, there are situations where use of one of the function is helpful to avoid ambiguity. For example, consider. So we have here one array, 1, 2, and 3, 4. The untyped return is taken as an array, so it becomes 1, 2, 3, 4. Then we have 1, 2, and then we have 7. This is a malformed array literal, so we will get an error. Then we have array 1, 2 with null. So this is an malformed array literal, but it won't show an error. But if you say array append with null, then it will append the null. In the examples above, the parser sees an interior array on one side of the concatenation operator and a constant of undetermined type on the other. The heuristic it uses to resolve the constant type is to assume that it is of the same type as the operator's other input, in this case integer array. So the concatenation operator is presumed to represent array cat, not array append. When that is the wrong choice, it will be fixed by passing the constant to array's element type, but explicit use of array append might be a preferable solution. So in this case, you see that concatenation operator doesn't work, but this is how you can append array to null. You can append null to an array. Now we come to searching in arrays. To search for a value in array, each value must be checked. This can be done manually if you know the size of the array. For example, select star from employee where pay by quarter 1 equals to 10,000 or pay by quarter 2 equals to 10,000 and so on. However, this quickly becomes tedious for large array and is not very helpful if the size of array is unknown. Alternative method is described in section 9.25. The above query could be replaced by select star from sal underscore in where 10,000 is equal to any pay by quarter. In addition, you can find those where the array has value equal to 10,000. Select star from sal underscore employee where 10,000 is equal to all pay by quarter. Alternatively, the generate subscript function can be used. So the subquery here is select pay by quarter, generate subscript pay by quarter, 1 as s from sal underscore m, and then you select this everything from this as full. Where pay by quarter s is equal to 10,000. So this will generate your subscript, and then it will have that. This function is described in table 9.70. We will see we will reach chapter 9 very soon. We can also search an array using the ampersand operator. It checks whether the left operand overlaps with the right operand. For instance, select star from sal underscore m to pay by quarter ampersand array 10,000. This and the other operators, others are operated. These are discussed in section 9 and then chapter 11. We can also search for specific value in the array using array position and array positions functions. The former returns a subscript of the first occurrence of the value in array, The latter returns an array with the subscripts of all addresses in the value of array. For example, select array position. Array Sunday, Monday, all the weekdays are there, and we are looking for Monday. The position would be 2. And if in this array, if you are looking for 1, then it will give you positions 1 for 8. Arrays are not sets. Searching for specific array elements can be a sign of database design. Consider using a subject table with a row for each item. That would be an array element. This would be easier to search and is likely to scale better for large number of elements. So let's see how much we have remaining. Array input and output syntax. Okay, we'll finish this. The external text representation of an array value consists of items that are interpreted according to the IO conversion rules for the array's increment type plus declaration that indicates their structure. The declaration consists of curly braces around the array value plus delimiter characters between adjacent items. There is a piece of warning here, okay? For example, if you are using raw SQL queries and you are using Python list and you are trying to insert list into array of, say, PostgreSQL, then it won't work because Python uses brackets for list. So you will have to do some manipulation and make a string such that the declaration or the closures of list are braces. I have faced this problem when I worked with Python. The delimiter character is usually a comma but can be something else. It is determined by the type element setting in the array's element type. Along the standard data types provided in the PostgreSQL, which we have already studied. The array output routine would put double quotes around elements values if they are empty strings, contain curly braces, delimiter characters, double quotes, backslashes, or white spaces, or match the word null. Double quotes and backslashes embedded in element value will be backslash escape. For numeric data types, it is safe to assume that double quotes will never appear, but for textual data types, one should be prepared to cope with either the presence or absence of quotes. By default, the lower bound index value of an array dimension is set to 1 to represent arrays with other lower bounds. The array subscript changes can be specified explicitly before writing the array content. This declaration consists of square brackets around each array dimensions lower and upper bounds with the column delimiter character in between. The array dimension declaration is followed by an equal sign, for example. So the subquery is we are selecting 1 colon 1 minus 2 colon 1, 3 colon 5. So 1 colon 1 means the first element, take this, and minus 2 minus 1. That. So minus 2, if you consider this, and minus 1 this. I am confused about this. I don't know how to read this query, okay? So let's see. So F1, 1 minus 2 and minus 3. 1 minus 2 and 3. So 1 is the lower bound here, 1. And then minus 1 would be this one. Hang on. Oh, this is a 3-dimensional. Sorry, this is a triple array. So 1 colon 1 will be the entire thing. Okay? Then minus 2 will be this, and minus 1 will be this. Okay? And then 3 colon 5. So 3 would be this, and 5 would be this. Okay? There are 2 elements here. Now, F1, 1 minus 2. So 1 would be the entire stuff. Then minus 2 would be this one. And then 3 would be, 3 should be this, because it is from 3, 5. So that's how we got 1 for this one. And then we have 1. So 1 would be 1 colon 1. 1 would be entire one. And then minus 1. So minus 1 would be this one. And then 5. So 3 to 5. So this would be 3, 4, and 5. So 6 is selected. So that's how we have to deconstruct this. Sometimes we have to apply logic. The array output routine will include explicit dimensions in result only when there are one or more lower bounds different from 1. If the value returned for an element is null, the element is taken to be null. The presence of any quotes or backslashes disable this and allows the literal string value null to be entered. Also, for backward compatibility with P8.2 version of PostgreSQL, the array underscore nulls consideration parameter can be turned off to suppress recognition of null as a null. As shown previously, when writing an array value, you can use double quotes around any individual array element. You must do so if the element value would otherwise confuse the array value parser. For example, elements consisting curly braces, commas, or the data types delimiter character, double quotes, backslashes, or leading or trailing white spaces must be double quoted. Empty strings and string matching with word null must be quoted too. To put a double quote or backslash in a quoted array element value, precede it with a backslash. Alternatively, you can avoid quotes and use backslash skipping to protect all data types that could otherwise be taken as syntax. You can add white space before a left brace or a right brace. You can also add white space before or after any individual item string. In all these cases, the white space will be ignored. However, white space within double quoted elements or surrounded on both sides by non-white space characters of an element is not ignored. So we have a tip. The array constructor syntax section 4.2.12 is often easier to work than the array literal syntax when writing array values in SQL. An array individual element values are written in the same way they will be written when not members of an array. So if you want, you can go ahead and look at 4.2.12. So this will help you understand. We have not gone through this value expressions because I thought data types would be the first thing we should study. So with this, we come to the end of arrays. We come to the end of array data type, and I don't think there is a practical example is needed or practical video is needed for array data type because the documentation gave plenty of examples in detail. So in the next video, we will study composite data type. And as I said that I will try to make PostgreSQL videos on daily basis because I want to finish this fast so that we can do web development and other related stuff which we can do with PostgreSQL and possibly explore Cockroach DB. And see also on the deployment side, I want to show you how to replicate, how to load balance, and how to do connection pooling and all those common administrative stuff. So I have 2 more videos to make of Python, and then I will make a daily video on PostgreSQL. So I hope that you are enjoying this read walkthrough with me and learning. I'm also learning a lot of things. So I hope that you are enjoying this, and thanks a lot for watching the video. I'll see you in the next one. Till then, stay curious.